Now that I've talked to you about blood pressure, we're going to go back and look at the vessels a little more closely because now we know how important it is to maintain blood pressure. So here are the arteries and arterioles. And we've already introduced these three different types, well, two types of arteries, elastic and muscular, and then arterioles. And you've looked at the sizes of these. These elastic arteries are also called conducting. These elastic fibers allow them to stretch and then recoil when blood is coming through, blood coming right from the heart, right? So the aorta is an example of an elastic artery. This elastic tissue would continue further from the aorta as well. These are fairly large and just going to conduct. The job is to conduct blood away from the heart and maintain that pressure without losing pressure because they're able to expand and recoil. If they were rigid, they would have high resistance. So their elasticness allows them to have low resistance and allow blood to pass through without losing pressure very quickly. Okay, so the next one is muscular artery. These are a little smaller and have mostly smooth muscle in their tunica media, right? That elastic tissue, that's the tunica media, where that is. I hope that's, you know that. Tunica media here is smooth muscle, which can contract or not contract to change the diameter of this lumen. Arterioles also have these same three tunics, but they're all thinner. And the tunica media is still the thickest. That's still smooth muscle. They're thinner overall. Again, there's variability in the thickness of all of these. And most important is this is the place where diameter changes the most. So this smooth muscle is super important here as well, but these ones are so important, they're called resistance vessels. They can become more or less resistant, increase resistance, or decrease resistance in order to regulate blood pressure. Let's look at doing this. So here are, this would be muscular arteries and arterioles. Arterioles do this the most. There's just the most of them. There's a lot more arterioles because we split already, it was branching. What's happening, here's our normal cross-section of arteriole. What's happening in each of these and what is the result of this? So what's happening is a change in lumen diameter. Specifically, here we have a decrease in lumen diameter that would also increase lumen radius, right, which is the ones in the equation for resistance. And this one is an increase in lumen diameter. The result is decreased flow. Why? We had increased resistance because we decreased the lumen diameter, decreasing radius. You could actually put that in your equation, right? For how that affects resistance. Decreasing the radius increases resistance. If you want to look at the equation, go for it. This is going to have increased flow because we have decreased resistance. And you don't need the equation, right? You also can see that there's less blood is going to be in contact with the vessel wall, which is the source of resistance that we're talking about here. One last thing here, why does this happen? How did this happen? Well, smooth muscle, right? We've got smooth muscle in the tunica media, and that smooth muscle contracts or dilates. So this here, number one, is called vasoconstriction. This is called vasodilation. And these can be regulated by various things, but largely the autonomic nervous system. And so we'll talk about that when we talk about regulation of blood pressure.